Hello, my name is Sahil Rajesh Kolankar and I am MBA in Finance and my team name is Connecting Dots and my topic for today is Rossman Retail Sales Prediction. These are my team members and I'm going to present my presentation. So, Dirk Rossman GmbH, commonly referred to as Rossman, is one of the largest drugstore chains with around 56,000 total employees. The product range includes 21,700 items and can vary depending on size of the shop, location, in addition to drugstore goods with focus on skin, hair, body, baby health, pet food, a photo service and wide range of natural foods and wines. Rossmann has 29 private brands with 4,600 products as of 2019. So the points of discussion for this presentation will be the problem statements, understanding the dataset, data preprocessing, exploratory data analysis, feature engineering, ML model, feature importance, and our champion model performance that has emerged from our ML model analysis, and the challenges that we faced in solving this problem dataset, and the conclusions derived from it. So the problem statement for our data set the was as follows. Rossmann operates over 3,000 drugstores in 7 European countries. The Rossmann store managers are tasked with predicting daily sales for up to 6 weeks in advance. Store sales are influenced by many factors including promotions, competition, school, state holidays, seasonality, locality. With thousands of individual managers predicting sales based on their unique circumstances, the accuracy of results can be quite varied. We were provided historical sales data for 1,115 Rossmann stores. The task is to forecast the sales column for the test set. So let us understand the data set. The Rossmann stores data CSV contain historical data including the sales, which is our dependent column. We also have the store CSV file which contains supplementary information about the stores. We had to merge our data set. After merging the data sets, we had these many number of records and 18 number of fields in a data set. So the data fields were mostly self-explanatory, but most that were not self-explanatory we have discussed as follows. Store contains a unique ID for each store. Sales contain the given turnover for the day, which is what we will be predicting. The customers contains the number of customers in a given day. Open states whether the store was open on that particular day or not. State holiday indicates a state holiday. A stands for public holiday, B stands for Easter holiday, C stands for Christmas, 0 stands for no holidays. School holiday indicates if the store was affected by closure of public schools. Store type differentiates between 4 different store models. Assortment describes the assortment level. A is equal to basic, B is equal to extra, C is equal to extended. Competition distance shows the distance in meters to the nearest competitor store, and the competition open since month or year gives the approximate year and month of the time of the nearest competitor that was opened. Promo indicates whether a store is running a promo on that day. Promo 2 is a continuing and consecutive promotion for some stores. 0 is not participating. 1 is store. 1 means that the store is participating in promo. Promo 2 since year week describes the year and calendar week for when the store started participating promo 2. Promo interval contains the consecutive interval promo 2 is started in the months promotion is started anew, February, May, August, etc. So the data preprocessing. Uh, First step was data preprocessing. Data running and processing requires cleaning of data, preparing it for further analysis. Our cleaning process involved the following parts: merging the both data set. We had to merge the two CSV files that were available to us. Then we extracted the date, year, month, day, week of the year from the date column for the analysis and dropped the original date column. We have created a new column called promo open from existing columns to measure more accurate period in months from when the store is participating in promo 2. We have created a new column called competition open from existing column to measure more accurate period in months from when the nearest competition has opened. We replace the negative values present in promo open and competition open with 0 value. Next, we treated the null values. We found that whenever the store was not participating in promo 2, we had null values present in store promo open and promo interval columns. So we have imputed those null values with 0 because logically when promo 2 is 0, then promo open and promo interval should be 0 as well. We have replaced null values present in competition distance column with median as the competition distribution was skewed towards the right. We have replaced the null values present in competition open column with mode as competition column was made by combining two categorical columns. Then we change data types of few columns such as competition open since month, competition open since year, promo to since week, and promo to since year. Then we handle outliers by using the box plots. Then we did some basic EDA. Assortment contained basic, extra, extended. State holidays denotes public holiday, Easter holiday, Christmas holiday, and none. The conclusion that we derived from our first EDA was the store model A have the maximum number of sales and store counts followed by D, while store model B had the least number of sales and store counts. This is shown by this bar chart. Next conclusion was store model B, which have least number of store counts, perform quite well on average sales and customers compared to the other store models. Basic assortment level have maximum number of sales and store counts followed by extended levels, while extra assortment have the least number of sales and store counts. Assortment level B with least store counts have performed quite well compared to A, while there is another surprising fact that assortment C have maximum number of sales with least number of customers. Store model B has the maximum number of sales at all assortment level. Assortment B is only available in a store level B. There is a linear relationship between customers and sales as it is shown by a scatter plot that we have performed in EDA. Sales and customers are highest on the 30th day of the month, followed by 2nd and 4th date of the month, while sales and customers are lowest on 1st of every month, followed by 25th and 26th day. Sales and customers are at maximum on Mondays, while sales and customers are nearly zero on Sundays because it seems like store used to remain closed on Sundays. Sales and customers are at peak during November and December due to festive seasons like Christmas, while sales and customers are lowest during January, May, or we may say that these months to be off seasons. Mostly stores were not far from the competitors, and the stores were densely located near each other. Surprisingly, sales were higher when competition was near. Stores has made more sales during public holidays compared to Easter and Christmas holidays. The impact of school holidays on sales is shown by this bar chart, as 82.2% was not school did not affect our sales, while 17.8% did affect our sales. Next, before proceeding to ML model, we did some feature engineering to simplify and speed up data transformation while also enhancing model accuracy. We did square root transformation to remove the right skewness from the dependent variable. Multi-collinearity, we didn't find any correlation between independent variables, but we found some correlation between dependent features, which is a good sign of our model. Feature selection. After analysis of each column, we found that the store columns have all unique values, which won't help in any prediction, so we dropped that column. Scaling numerical features. We use min-max scaler to scale the numerical variables, customers, competition distance, year, month, day of the week, day, competition open, which we are within given range of 0 to 1. Dummification. We use dummies to convert categorical variables, state, holiday into dummies variables of 1 and 0. After performing all these steps, the data set is ready for ML modeling. Now we train a model over a set of data, providing it an algorithm that can use to reason over and learn from those data, then making predictions on those data which hasn't been seen. After performing various regression techniques on our predictive model, and we found that XGBoost regression and random forest regression perform better than any other regression model with 98.8% and 99.4% accuracy respectively, as it is shown by our table. Random forest and XGBoost. After performing various regression techniques on predictive model, we found that XGBoost and random forest perform better than any other regression model, 98 and 94% accuracy respectively. The best parameters for our tuned models were as follows. Best parameter for lasso regression according to GCO, the alpha is equal to 0.0. Best parameter for regression according to GCV was alpha is equal to 0.25. Best parameter for decision tree regression according to GCV was max depth equal to none and min sample leaf equal to 7. After selecting XGBoost regression model, we can see the importance of each model, each features of a model dataset. The customers had both the most importance. After that, assortment B had the next feature importance, store type D had the next feature importance, and so on. The performance of our model using cross-validation method of sklearn showed that average time for fitting the estimator on train set is 35.446. The average time for scoring the estimator on test set is 0.15. The average R2 score for cross-validation is 0.99. The challenges that we faced while performing this EDA was handling and understanding large number of data. We had almost these number of records and 18 number of fields. Columns with improper data type, wrong values, combining, creating, removing columns were also a challenge. Records containing more than 50% null values and replacing it with substitutes. Removing and replacing the outliers from dependent and independent variables. Reducing the skewness from the variables, feature selection for the ML model. Converting the columns with categorical variables into integer type and scaling numerical variables for regression models. Performing and choosing the right kind of model, hyperparameter tuning consumed a lot of time and computational resources. The conclusion that we have derived were as follows. Store model B has the least number of stores in Rossman, that it performed well and made more sales than any other store models. So it is advisable to increase the number of store B model. Assortment level basic have the maximum number of stores in Rossman, yet it performed very badly. But at the same time, extended assortment level with less number of store had performed extraordinarily, so it would be advisable to increase these assortment levels. In a relationship having formed with customer sales and promo, it has been seen that most of the customers came from shopping during the promo days as the cost was lower on those days. So promo should be initiated to more sales to increase the sales. Sales had been low on initial days of the month compared to the end of the year. It can be assumed that people used to shop for the next month at the end of the previous month. Those products can be mainly because of basic necessities for person's daily life. Thank you.